Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. Today's continuation of the miniature drill press build brings us to the upper section right here. This is component number 2. This is the frame. And as far as the frame goes, this is the actual frame. Let's take a look at this. Two different diameters here. These diameters are the same. It looks like this sweeping detail on the back is probably the same gauge, which is good. That's very helpful. And from the bottom, from the frame where it connects to the tube all the way to the upper part of the head is one continuous decreasing diameter. So that's a sweeping radius or sweeping trajectory, whatever you want to call that. But it's certainly going to pose problems on how to hold this. You want to access as many of these surfaces as you can from the initial setup, but you want to make sure that everything is straight. And the way this thing sits right now, it doesn't exactly sit straight on any surface that you want to sit it on. So the fixturing is going to be key. The fixturing will have to get a little creative, and with any kind of luck, it won't have to come out of the fixture until it's done. That's the plan. Let's do it. Like any casting, first step is to remove all the flash lines, gates, sprues, risers, vents, whatever you can do. Clean it up, clean it up. That way, with all the surfaces true, all the surfaces blasted, you'll know exactly what you have to work with. It's not going to take a whole lot of work. These parting lines on this are very good. The alignment, I would say, is better than average. I am very pleased with that. So a little bit of file work back in the blaster, and we'll get this thing ready to rock. Give me a few minutes off camera here with the file. Probably more than a few minutes, but nothing elaborate. I'll put it in the blaster, and we'll be right back. After a little bit of bench time, file in hand, all the parting lines are gone, all the diameters are cleaned up, except for the faces that will be machined, of course. This casting was pretty clean. A little bit of vertical offset, but the side-to-side alignment was just beautiful. Very pleased with this one. This was a breeze to clean up. Everything was accessible and a light blasting after the fact. Now it's time to get into the fixture. I do believe that the base features for this particular component has to be this rib on the back of the part. That is the only thing you can count on. Everything else changes as it goes high, low, left, and right. These two diameters on the front for the main spindle are different diameters. The ones on top are different than the top of this one. And I believe they are also bigger than this rib on the back. The concept behind this fixture will be to trap this arm back here. And that should get everything in line on the fixture. And then it's just a matter of being able to access all the inner points for the milling. So these will all be side milled, and then I'll be able to stand the fixture up and drill everything in line. Ideally, I would like to put something in between these two bosses because they're very far apart, and you don't want the drill walking off doing whatever it needs to do between these two. So a little bit of slave material in the center to act as a guide is probably highly suggested. Let me grab a piece of stock from my holding area and see what I can come up with. I'll share it with you when I get it done. Let's take a quick look at the final fixture configuration. I had initially had this part positioned this way, and looking at the print, there are more features down here that need to be addressed as well. So keeping with the logic of keeping the part on the fixture, this is what we come up with. That's what I came up with. The upper block will be used as a drill guide when the drill passes through here and here. It should stay on track for the completion over here. The way the part is also dimensioned, it allows me to make my skin cut down here and find the center across those two journals, which is good. These guys here are different diameters, so there will need to be an offset from here to here. I'm going to show you how I'm going to do that. I think it's a pretty good idea. You can indicate it, you can make a block, whatever, but I'm going to use a couple of pins, and I think you're going to like the logic behind it. The hold down plate will sit right here, trap the whole thing in place, and allow me access to all the surfaces I need to access. So this little fixture ought to work pretty good. They always work good on paper, right? Let's put it in the machine and see how it performs. The part is now ideally situated in this little fixture that I just built. Two different diameters here. This diameter is smaller than this one, and these guys in the back are the same size. Now, in order to align this, I used what I think is a relatively reliable method. Going back to the pins. Find a pin this size. Right there. Find a pin that size. Right there. Now, you don't just find these pins. You go to your gauge pin set and pull them out if you have it. If you don't, then do it a different way. So now how are you going to use these? This is the same size as the front. This is the same size as the back. Here's where it gets clever. I am going to put the big pin in the drill chuck and come down on the model with it. Now see if you can follow along. The little diameter plus the big diameter has a very specific dimension from the center of that pin to the center of that boss. Correct? Correct. When you move to the front, use the smaller pin, because collectively it's the same combination of radiuses and it's a straight line. So what I'm looking for right now is the gap between that pin and this boss, and when I change it to the smaller pin and move to the front, I'll look for the same gap. That will tell me that the radius of this plus the pin, the radius of this plus the part will be exactly the same. And I've already done this off camera, so I know it's going to work. I'm going to move this over until it traps that paper. And my digital readout right now is saying 2.5 thousandths, which is about the thickness of the paper, so I'm pleased with that. Let's go to the smaller pin. And move it back. I'd be looking for 2.5 thousandths on the digital readout again. Let's see if that happens. This one actually chokes the paper at 3 thousandths, which is a 0.5 thousandth out. I'll take it. It's a casting. Could be the difference in a file pass. Looking at this part profile now, the pin in the drill chuck is the size of these two small protrusions on top of this casting. Visually align it to both of them. See that it blocks out that one just perfectly. Let's step over to the other side. Block this one out too. At this point, you can trust the fact that this casting is positioned as intended, that all the features are going to go through the center of the bosses now. And right now I'm going to set my y-axis to 0, and based on the size of my cutter, I will know where the end of the part is right here. And I can establish that dimension. It's a great way to do it. I trust it. I'm going to proceed down this path. Just because I think it's really important that you grasp what you just saw in the mill, I think this piece of paper here is going to explain it very well. Looking down on the part, this is the small cylinder, this is the big cylinder. The big cylinder has a pin the same size as the cylinder. The little cylinder has a pin the same size as that cylinder. Let's call these parts A, part B. So you have radius B, half the small cylinder. Radius A, half the big cylinder. When you put that back here and you put this right here, those center lines are the same. That is the y-axis movement of the machine when I use the piece of paper between the cutter or between the pin and the part. You can see that radius A plus radius B will always equal radius B plus radius A. It is a straight line across an uneven surface. Very reliable. Keep that one in your mental toolbox. It's a good way to use pins. It's a good way to find irregular surfaces. Now, realistically, on the print, there are only 2 called out dimensions for cleaning up the frame. Actually, 3. That face, this face, and the inside of the back face, and the bottom itself. Everything else is going to be cleaned up just for a visual clean and a solid stop surface. Fixture is now repositioned vertically in the vise, and I'm going to install the features in the bottom that accept the column. Visual alignment with a pin the same size as the column, so that when the column is installed, it is aesthetically aligned with the casting. Drill it, tap it, counterbore it. Let's do it. Keep a close eye on the top of the part as the drill makes its initial contact. You can see it start to flex right there. Now, from where I was standing, that was pretty clear and unacceptable. I don't know how fragile these things are. The last thing I want to do is crack the casting. Also, I grab another drill the same size, thinking that one might be dull. Lo and behold, the second one I grabbed had a bad point. Edges were good. Still got the deflection. Still not acceptable. You want to reduce pressure, reduce the size. Third time's a charm. Go with a smaller drill. You can see that deflection, although minimal at this point, is still present. Be very careful if you're doing this. This is a delicate operation. Now I'm going to drill down through the block and ultimately down through the bottom journal. And this is all being done in sequence. I will finish ream the top hole and ream halfway through that guide block, but I will not ream all the way through the guide block yet because I want a guide for the small drill to drill the bottom journal. Well, that's a lot to absorb, but that's how it's got to be. With the larger hole on top, the evacuation of the chips from the flutes on the smaller drill now has a place to go without ruining the finish or the size of the top hole. And as you will find out someday, there is nothing worse than grabbing a drill right on the very end of the drill because it has a tendency to run out like a fly cutter. This is when it's a good time to have that lower guide hole the same size as the drill that you're using. And it worked out quite well because I'm choking up on about 1/4 of an inch or less of this drill to make it all the way through the part and the block. As the drills get bigger in size, naturally they're going to get a little bit longer, and the only tool that you can trust in this operation, unless you have a jobber drill, extended length, or an aircraft drill to get through it, is the reamer. Reamers are normally longer than the drills that they accommodate. So I'm going to feed the drill down into the guide hole and now engage the chuck on the drill and start it up. A very superficial grip on this drill, but I'm working in very confined spaces with limited length tooling, so this should be sufficient, and it proved to be. That's a win. Nice and smooth. Now in the vertical format, if I were to lose position, I could simply leave the rod in and indicate it for the spindle holes. Next operation is the spindle hole right here. This is a 125 or 1/8 3mm, and this is a 250. Naturally, you would think you're going to do it from this side, make the bigger hole, because you can't put a 250 hole here if you do it from this side. But you can't locate this hole if it's standing upright to do that, because these holes are positioned from this face right here. So we're going to go against convention. Stand the fixture up, locate this face without moving the table because the table is already centered for these holes. And I'm going to put the 125 through here and through here. Invert the fixture, pick up the pin, and do the counterbore work on the lower half. Due to a limited amount of space on the face of the arbor, I elected to hold it sideways, stood it vertically against the square, and used the spindle rod from the previous operation to indicate and find the center line on the X, edge find this face, and move out for the center line on the Y. This feature will produce basically a 1/8 reamed hole going straight down through the center. And then I'll move up to these little oiler cups right here. Well, they're just called out for holes, but you know I'm not going to let that go. They're going to end up threaded with cups on it, so let's do it. If everything's gone well during the machining process, this is what you should have. You should have a spindle that goes nicely through the spindle bushing. The bushing goes through the frame. Everything lines up. Everything spins freely. Everything moves as it should. The gears up here on the end. This is where the cone pulley will sit. The cone pulley will drive this shaft, turn these gears, and in turn this gear, which is key to the shaft. And as the spindle goes up and down, this shaft will come through here and clear the whole assembly. All the hand crank mechanisms, all the gears, all the cross slide stuff, or all the cross shafts are referenced to the center line of this guy that has a rack on it, or will have a rack on it. So that's going to have to be the next step. I'm going to have to modify this piece here, put a rack on it, and then we can start to do the cross holes and the pinions and worms that make it go up and down. So far, the fixture's performed very well. I'm pleased. This may be it for this episode. Thank you very much for tuning in. I hope you like what you see, and if you're building this kit, I hope it gave you some ideas. And wherever you are in the world, I hope you are well and happy and safe. I personally feel like I have a hangover. I got a booster shot yesterday for this COVID variant, and it's kicking my butt. On that note, Joe Pye, Advanced Innovations in Austin, Texas. I'm out. Now, I thought you guys might like a look at the mini drill press vise sitting on the drill press table, so it's a little bonus material for you. I think the scale is good. All is well.